Happy Monday, my favorites. It's Miss Hill, and I just wanted to check in and spend a little bit of time talking about the notes for this lesson. So this lesson is wrapping up all of Unit 6. So if you're starting to have a little trouble pulling it all together, that's totally normal and completely okay right now. We're just going to take it step by step together. So on the screen right now, I've got just a reminder about my Google Hangouts and the Flipgrid check-ins. So Tuesdays and Wednesdays from 1:30 to 3, I hang out on Google Hangouts and go over practice problems and answer questions, anything that works for you. So show up. I will always send a reminder on Google Classroom for you and give you the link. It's the same link every time. So come by, ask a question, say hi. I would love to see your faces. And then on Thursdays from 1:30 to 3, I am live, which just means that I am hanging out in the Flipgrid that I will send you the link to every Thursday morning. And this is a place where you could send me a video question, you can post a question, and then I'll respond right away with a video back to you. I am going to make those videos private, so only you and I can see each other's videos. You don't need to worry about everybody else looking at your videos anymore. So I will make sure that those are private. But join me on Flipgrid on Thursday afternoons and say hi with a video or ask a question. You don't have to show your face if you don't want to. There also on the screen is all of my contact information. Again, Fridays I will post your answer key, and that's what I'm looking for you to grade or correct your work and then post your final product of your worksheet to our assignment. Great job to everybody who's been doing that. So let's dig into 6.5 angle relationships. So this is our last lesson in Unit 6. And what it's doing is it's teaching you one more piece about angles, and then it's summing the whole thing up. So you're trying to connect all of this information that you've had for the last couple of months since we had a little break there. So I put a little reminder there in pink just to remind you about some things that are important. So again, this lesson, the essential question is, can I use special angle relationships to find angle measures? So I'm using all the special relationships of angles together. Some angle relationships to remember from your past lessons: parallel. Those are two lines that are never going to intersect, and intersect just means cross. Transversals. So a transversal is that kind of diagonal looking line that crosses over two parallels. So if you have two parallel lines and then you've got that one that comes kind of diagonally through them, that's called a transversal. Angle pairs. Some examples of angle pairs are your alternate exterior and interior angles. You guys talked about corresponding angles for a while when you were back in school. So there were a couple of different kinds of angle pairs. And then sum of angles in a triangle. That's actually a lesson that we started with in our distance learning. So all triangles are going to add up to 180. Super important info. Okay. So if you look at the first example, they're talking to you, the first vocab example, they're talking to you about exterior angles. So if you think about interiors, like inside the house, exterior is outside of the house. Same thing with angles. An exterior angle is the angle that's outside of the triangle or the shape. So if you look, I drew two little pink arrows towards some exterior angles. So angle 3 is an exterior angle. It's outside of the triangle. It's not part of that 180 on the inside. It's outside of the triangle, but it's formed by that line that's across the bottom, right? That's outside of the triangle, as well as that edge of the triangle. I also drew another angle, so the angle that's outside of angle number 1 would also be an exterior angle. Another term to know is remote interior. So think about like your remote control that you use for your TV. It's not like you have to touch your TV with the remote, right? It doesn't touch. You're sitting over across the room, you've got this thing in your hand, and you're able to affect what's on the television. Same thing with these interior angles. Your remote interior angles are two angles that are inside the triangle, but they are not touching that exterior angle. So in that original example I drew, angles 1 and 2 would be called the remote interior. It's like they're sitting across the room on the couch, right? And they're affecting angle number 3. So they're changing the channel. 1 plus 2, so angle 1 plus angle 2 is going to equal angle 3. And that's what this exterior angles theorem was all about. So again, these notes are from that original video that I posted from Ed Gems. Remember the fancy word theorem right here, that's just, again, fancy math language for a theory. And a theory really is a rule that we've come up with, a rule that we believe to be true. And what we believe to be true about these angles inside and outside of a triangle, like that example we drew, is that if I add up angle 1 with angle number 2, the sum that I get from those two angles is going to give me that exterior angle, which is angle 3. So two remote interior angles add up to equal that exterior angle. Let's look at some examples about when we might use this. So again, this is all directly from the video that you just watched, and I'll walk you through it. So example number 1, I've got this exterior angle of X, and then I have these two remote interior angles, 78 and 35. If I want to know the measure of that angle X that's on the outside of my angle, I can just add up those two interior remote angles, 78 plus 35, and that is always going to give me that value of that exterior angle that is across, remember, sitting across the room with your remote, across that exterior angle, which is 113. For example B, this time they gave me the exterior angle and they gave me one of the remote interior angles. So I'm going to write a little math sentence that just says if I take 26 and I add up X, don't know what that is, what I'll get is this exterior angle over here. So I'm using the same rule, it just looks backwards because of what I know. If I subtract 26 from both sides, that's going to give me the value of X, which is 122. Extra example C on the video is doing the same thing, except they threw in one other little change, which is they drew the symbol for a right angle. A right angle is always 90 degrees. So I'm going to do the same thing I did with example B. I'm going to take, well, I've got the 90, and I've got this X over here in the corner that I don't know. These two angles, those are my remote interiors. Those should equal this exterior angle, which is 137. Again, subtract 90 and you get 47. Super awesome surprise. Do not worry about example number 2 from the video. That is not something that we are going to worry about right now. So moving on. Example number 3. Example number 3 is taking everything you have learned about all of your angle relationships and compiling it into one problem. So for a problem like example 3 or extra example 3, if those are below in your mind, that is okay. It's kind of taking all the pieces and seeing what you can connect together. So slow and methodical wins the race in this one. So example number 3, they give me this triangle inside of a triangle. If you can envision triangle AHE, or they're calling it HAE. That is a smaller, similar triangle, not congruent, but similar, that is inside of this larger triangle. Okay, what we know about similar triangles is that their angles are going to be equal to each other and that there's going to be a proportional relationship to their sides. So if you notice, they asked me, what is the measure of angle HAE? So that's this angle. If I start at H and I travel to A and then I go to E, that's angle HAE. That measurement right here is going to be equal to that same angle that's in the same spot on the larger or similar triangle. So HAE is going to be equal to HTY. that angle. So A and T are going to be the same because those are corresponding angles. So I can just say that that would also be 58 degrees. For the measure of angle Y, I'm actually looking at this angle right here. And that angle I can find. Now I don't have E, so I can't compare it to the one above it. But what I do know is that all the angles inside a triangle add up to 180 degrees. So if I take this measure of T, which I just found is 58, and I take the measure of H, which they gave me in the problem is 77, and I add Y, that's what I'm looking for, I know that's going to add up to 180 because every single triangle adds up to 180. Go ahead and combine like terms. 58 plus 77 is 135. Subtract 135 from both sides, and you found that the measure of angle Y is 45 degrees. The last part of this problem was solving for C. Now X is one of the sides, and that's where I'm going to use the idea that similar triangles have proportional sides. So I'm going to set up a proportion to compare the sides that are related or corresponding. So side X, which is what I'm looking for, is at the bottom of that first smaller triangle, and this side, TY, is at the bottom of the larger triangle. So I'm going to compare those two sides. I'm going to say X is in proportion to 21 in the same way that this side HE over here, which is 6, so notice that's the side from the smaller triangle. So X is the smaller triangle, and this side 6 is also the smaller triangle. And I'm going to compare 6 with the whole side. So I'm comparing smaller triangle to larger triangle. So to get that 14, I added 6 plus 8, so that I'm talking about that entire side. Once I've set up that proportion, I'm going to cross multiply. X times 14 gives me 14x. 21 times 6 is 126. Divide by 14, and x is 9. The last example that they gave you in the video was talking about this picture. And again, it's another example of taking everything that you've learned in this entire unit and pooling it together. So for A, the measure of HLN, so if I follow that line, HLN, I'm looking for this angle here in the corner. That angle is going to be the same measurement as the angle in the smaller triangle that's in the same place. So that's going to be this 35 degrees. Those are corresponding angles, so they have the same measurement. Same thing goes with RKH. So if I follow that path, RKH, I'm looking at this angle right here. That is going to be the same measurement as its corresponding angle in the larger triangle, which is this 55 degrees, or N. Those are in the same locations. Those are corresponding. They're going to have the same value. To solve for the last two pieces, and I'm trying to show you on the screen the question as well as the original diagram. So in this last C and D, I'm looking for the value of H, R, K. So I'm looking for this angle up here. Now, what I found out when I solved the other two problems was that I found out that this angle here is 35, and I already knew that that angle there is 55. So what I also know about triangles is that all the angles inside add up to 180 degrees. So I'm going to take the 35 that I found out from L, I'm going to add 55, and the remainder for 180 degrees will be my value of R. So let me show that to you. If I take 35 and I add 55, that's going to give me 90. Subtract 90 off of both sides, and you've found that the measure of angle R, or HRK, is going to be 90 degrees. The last problem is a side problem, so I want to set up a proportion. Similar to the last example, if I am looking for this side here, X is in proportion to 24. Those are similar corresponding sides. And then what I can use is the values over here. So if I'm comparing x to the larger length of 24, I can compare 8 then to the larger length of 20. So I added the 8 and 12. So if I set up that same for that proportion, x is in relationship to 24 in the same way that 8 is in relationship to 20. And again, I got that by adding the 12 plus 8. I'm going to do my cross multiplication, which gives me 20x is equal to 192. Divide by 20, and x is 9.6. I know that was a lot of information. I tried to walk you through all of the pieces from the video. I do know you're going to want more practice and you probably have more questions. So please, please, please show up this week. I would love to see your face or hear your voice on my Google Hangouts, Tuesdays and Wednesdays, 1:30 to 3. I'll put the link back up on our Google Classroom. You can send me an email or a text or call me anytime. There's my information. You can also Instagram, Snapchat, email, whatever you want to do. Just get a hold of me if you have a question. I'll also be on Flipgrid on Thursdays. So whatever way of getting in touch with me works, please do so. Your assignment for this week is number 1, write down these notes. Make sure that they are in your math spiral. Number 2, you're going to complete the practice worksheet that I have posted. I'm only posting the practice and not the challenge this week. And the last thing that I want you to do this week is a little something extra. So all of the directions for it are on Google Classroom. I'm asking you to not only complete the worksheet this week, but also to take a minute and think of a creative way that you could express everything that you have learned about angle relationships. You can do a TikTok for me that's about angle relationships, Snapchat, Instagram. You can create your own video. You could write a poem. You could sketch something. You could take pictures in nature. Anything that expresses what you have learned about angles and what you're noticing about angles in life would be an absolutely fantastic way to show me what you know. So check out Google Classroom, look at all of the directions, get creative this week. Math is everywhere. So see what you can do. I can't wait to see your creations. Love you all, miss you all. You know how to get a hold of me. Bye.